Now last time we defined what a positive exponent is. Today we're going to build on that definition and define what a zero exponent and what a negative exponent means. First, let's define what an exponent of zero means. An exponent of zero means no factors of an object. And let's see what that works out to by looking at a couple examples. 2 to the 4th power means 2 times 2 times 2 times 2, which gives us a total of 16. 2 to the 3rd power means 2 times 2 times 2, which is a total of 8. 2 to the 2nd power means 2 times 2, which is an answer of 4. 2 to the 1st power means just one factor of 2, which gives us a 2. And 2 to the 0th power, a lot of people wonder what they ought to write here. If we look at the pattern that's been developing, to go from 16 down to 8, down to 4, down to 2, each time we're cutting that number in half. And so if we continue that pattern again, 2 to the 0th power ought to equal a 1. And in general, that's what anything raised to the 0th power is. Anything raised to the 0th power is equivalent to a 1. Now, while I'm on this page, let's continue this pattern and think, what would 2 to the negative 1st power be? Or 2 to the negative 2nd power? Or 2 to the negative 3rd power? If you notice, 4, 3, 2, 1, 0. The next exponent in line would be negative 1 and negative 2 and negative 3. If we were to continue this pattern down, divide by 2 gives us 8, divide by 2 gives us 4, divide by 2 gives us 2, divide by 2 gives us 1. 2 to the 1st power, or 2 to the negative 1st power, would mean to divide by 2 again, and that would give us 1/2. And 2 to the negative 2nd would mean to divide by 2 again. That would give us 1/4. And if we divided by 2 again, that gives us 1/8. And in general, I think we see that negative exponents mean repeated division. So a negative exponent means repeated division. And that could also often mean repeated multiplication by the reciprocal. Notice as a few examples, 2 to the negative 3rd we just found was 1/8. And notice that would be the same thing as if we had started with a 1 and divided by 2 and divided by 2 and divided by 2. But because all those divisions look pretty ugly and scary, a lot of times what we'll do is instead write 2 to the negative 3rd as 1/2 times 1/2 times 1/2. And multiplication of fractions is really easy. You just multiply the tops and multiply the bottoms, and that gives us our answer of 1/8. In this example, it might be a little scarier yet because you've got variables that are raised to negative exponents. But what this literally means is we would start with a 3, and then x to the negative 3rd would mean we would divide by x, and divide by x, and divide by x. And then y to the negative 2nd power would mean we divide by y and divide by y. That looks really scary, but if we instead wrote these divisions as multiplying by the reciprocal, 1 over x, 1 over x, 1 over x. Sorry, my x's look like y's. 1 over y and 1 over y. And this 3 is a 3 over 1. Then we could multiply all the tops together. 3 times 1 times 1 times, that's just 3 on top. And then on the bottom, we've got 1 times x times x times x, which is x cubed. And y times y is y squared. And this expression and this expression are equal. Typically, we say that this is the simplified version, because it doesn't have any negative exponents. Any negative exponents have found a spot in the denominator. Now, just like working with positive exponents, there are some helpful properties that can help us when working with negative exponents. And that is that first example that last example I just showed you, that when we had a variable raised to a negative exponent, that variable ended up just in the denominator with a positive exponent. So, my crazy math teacher used to say that negative exponents were kind of depressed, and they needed a space of their own. And if they moved their bedroom down into the basement, well, then all of a sudden they were happy and positive again. I don't know. It worked. It works for me. It's a little crazy, but I obviously remember it to this day. So now, the same thing could be said for any negative exponent that you see ending or see in the denominator. If you have a negative exponent in the denominator of a fraction already, a nice thing about this is that it can be rewritten as having a positive exponent in the numerator. Remember, this could be written as over 1. So, continuing that metaphor of depressed negative exponents, we could say that this exponent had a room downstairs and maybe got scared of the dark or the monsters or something like that, and so became depressed and negative. And when we repositioned it upstairs where everybody else lived, then all of a sudden it was positive again. So, finally, there are often times when you have a fraction that is as a whole raised to a negative exponent. This would be like an entire house that's depressed, and maybe if everybody moves, so the a's move down to the bottom and the denominator moves up to the top, well, if that's the case, then you can replace the negative exponent with a positive exponent. Let's look at a few examples that take advantage of these properties. In this example, I see 2x squared, and the squared is a positive exponent. And then here I've got 4y squared, which is raised to a negative exponent. By using this first property, that a group that's raised to the negative exponent can be rewritten in the denominator with a positive exponent, that suggests that this expression could be rewritten as 2x squared in the numerator and the group of 4y squared in the denominator, and now it has a positive exponent. This reminds me a lot of the shortcut that we have when working with equations, that if you switch sides, you switch signs. When we flipped these things down to the denominator, it switched sides from being on top of a fraction to the bottom of the fraction, and when it did that, it switched signs. Now we can use some of the properties from positive exponents to simplify this. On top, 2 squared and x squared, that's the same thing as 4x squared. And on the bottom, this cubed can apply to the 4. That's 4 times 4 times 4, or 64. And it can also apply to the y squared, which is y to the 6th power. And for reasons we'll get into a little bit more in our next video, 4 divided by 64, we would reduce that, and that would give us 1 over 4. The 1 on top we won't write because there's also this x squared. But on the bottom, we would write, I'm sorry, did I say 4? I think I did. 64, when you take out a factor of 4 from that, will give us 16 y to the 6th. As another example, I've got 3w to the negative 2nd power, x to the 4th, on top, y to the negative third, z cubed, and 2 to the negative fourth on the bottom. And this will take advantage of a couple properties, but mostly this one, that if I've got something in the bottom with a negative exponent, I can rewrite that on top as a positive exponent. So if I'm dividing by y to the negative third, that's the same thing as if I was multiplying by y to the positive third. Likewise, if I am dividing by 2 to the negative fourth, that's dividing by 1/2, dividing by 1/2, dividing by 1/2, dividing by 1/2. That's the same thing as multiplying by 2 to the positive fourth. These z's have a positive exponent already, and so they represent z's that are actually being divided and should be written in the denominator. These x's have a positive exponent, and so those should be fine where they are. These w's, however, have a negative exponent. What that means is that they probably should be written down in the denominator with a positive exponent of 2. And so this expression, if we clean it up a little bit, on top we've got factors, we've got numerical factors of 2 times 2 times 2 times 2 times 3. That's 16 times 3. It's a total of 48. And then we've got variable factors of y cubed and x to the fourth. We usually write the variables in alphabetical order, and so I'll write x to the fourth and y cubed. And then on the bottom, I don't have any number factors. I have letter factors of w squared and z to the third power. And so that's our final answer. And in our final example, I've got 3m to the negative fourth raised to the third times 5b to the 0th times c to the 10th, and that's all raised to the negative third. There's a number of different ways that we could move stuff around and address this particular one. I'm going to take advantage of the multiplication property of exponents, which was originally given to you when talking about positive exponents, but it also applies with negative exponents. And so I'm going to take this cubed and multiply it by each of the exponents in the group. 3 has technically got an exponent of 1. And so this part becomes 3 to the third power. And 3 times negative 4 means m to the negative 12th power. Then in this group, this 5 technically has a power of 1. And so 1 times negative 3 means 5 to the negative third power. This 0 exponent times negative 3 is still 0. And so b to the 0th power. I don't really need to write b to the 0th power. That's technically a 1, but anything times 1 is just anything, and so I'm going to leave that particular part out on purpose. And then finally, c to the 10th times negative 3, that's the same thing as c to the negative 30th. And now I've got some positive and some negative exponents, and so I'll move some stuff around using the negative exponent properties. That m to the negative 12th should be written in the denominator as m to the 12th. And 5 to the negative third should be written in the denominator as 5 to the third, or 125. 5 times 5 times 5. And then c to the negative 30th should be written in the denominator as c to the positive 30th. And if we clean this up a little bit, 3 times 3 times 3 is 27. That's the only thing that remained in the numerator. And in the bottom, the number factor usually goes first, so 125, and then the letter factors in alphabetical order, so that's c to the 30th times m to the 12th.